Good morning, everyone. Welcome to the fifth annual Discovery Farms Multi-State webinar. We really appreciate you choosing to spend time with us today, and we are excited to cover several water quality topics and the role of on-farm research in informing those topics with you. Over the course of the morning, we'll be featuring the work of Discovery Farms programs in Wisconsin, Minnesota, Arkansas, and Vermont. My name is Amber Raditz. I'll be the moderator for our webinar. I'm the Agriculture Water Quality Program Manager at the UW-Madison Division of Extension, which is the Wisconsin home of the Discovery Farms program. This multi-state effort is in place to provide farmers, farm advisors, and interested stakeholders with credible water quality research information. So a few housekeeping things before we get started. First, we encourage questions and discussions from you. Please put content-related questions in the Q&A box, which is found at the bottom of your screen. And you can put questions related to logistics like technology, agenda questions, or other things into the chat box, and we'll address those separately from the Q&A for our speakers. Secondly, if you would like to receive CCA credits for your time here today, we will show the QR code at the end of the session. At that time, you can scan the code from your phone to register for credits or put your CCA number in the chat and we can register them for you. There are 2 soil and water credits available for today's webinar. Each state will have 30 minutes of presentation time, including answering questions. Each speaker will answer questions at the end of their talk. There might be some time at the end of the session for questions, but we encourage you to ask those questions right away during the speaker time and also use the Q&A feature to vote for questions that resonate with you. This year is special for those of us who have worked closely with Discovery Farms as we're celebrating 25 years since the program was started in Wisconsin. We started our celebration during the Water and Soil Health Conference in December, and we'll continue through the year with some special videos and memories and summary of the program impact. Initially, Discovery Farms was formed in response to a call from the agriculture and environmental communities for enhanced on-farm research in the area of water quality. Farmers volunteered to host water quality monitoring stations in Wisconsin to better understand the dynamics of runoff timing, the impact of agricultural management, and the influence of weather. Over the years, programs have been added in Arkansas, Minnesota, and Vermont. Representatives from each state pursued the determination of Discovery Farms, which is a registered trademark, because of the positive response to the work of the program from farmers, farm advisors, agency partners, and water quality stakeholders. Each Discovery Farms program has to include the 3 pillars of Discovery Farms, including farmer leadership, credible water quality research, and communication of results. So let's get started with our speakers for today. Our first speaker of the day is Ellen Albright. Ellen started with Discovery Farms as a researcher in December 2023. In this role, she assists with maintaining on-farm field sites, data analysis and visualization, and building research partnerships. Ellen received her Bachelor's of Arts in Biology from Macalester College and her PhD in Freshwater and Marine Sciences from UW-Madison. Go ahead, Ellen.
Thank you, Amber. Thanks for getting us started. And thank you to all of you for joining us today. I'm going to go ahead and get my presentation shared. How's that looking?
That looks good.
Great. Well, as we celebrate 25 years of the Wisconsin program, for this event, we thought it would be fun to look back and highlight some key lessons learned from our surface runoff and tile drainage monitoring, and then also share an example of how we've used this monitoring data set to evaluate different ag conservation practices. So we'll start with our surface runoff data and looking specifically at seasonal patterns that we've seen in surface runoff. But first things first, just want to give a quick overview of how this data is collected in the first place. So all of our surface runoff monitoring sites are placed at a specific location at the edge of a farm field. It needs to be a spot where we know runoff water from an area within that field is going to flow. We further channel that water using an earthen berm so that all of the runoff water is going to be going through that green chute called a flume at the center. We use environmental sensors to continuously monitor the depth of water in the flume, and then that information is used to calculate runoff volumes. These stations are also equipped with automatic samplers, So when water runoff is happening, water samples are automatically collected from the flume and pumped into sample bottles in that gauge house or that silver box you see there. These water samples are then collected by a local partner or a Discovery Farm staff member and taken to a lab where they're analyzed for sediment and nutrient content. And these sites are all maintained in partnership with the U.S. Geologic Survey. So, what have we learned from this continuous year-round monitoring? Well, a key pattern that's emerged is that late winter, the time we're in now is really a key time for seeing runoff. So let's look at some of the evidence for this. And we're going to be looking at a number of figures that follow this format. So we're going to be looking at monthly median totals over all of our cropland sites. So we're just looking at January here to start as an example. The height of that bar there is showing us the median or the 50th percentile of the typical total runoff that we see for the month of January. And then we've further broken down that bar based on the typical contribution of runoff when soils are frozen versus not frozen. So as we'd expect for January, the vast majority is happening under frozen soil conditions, with just a little sliver from a more recent year happening under non-frozen conditions. And we define the soil as being frozen when there's any frost present in the top 40 centimeters. So now we can look at the rest of the year. And like I said, we really see this late winter time period, and especially February and March, as a key time when we see larger monthly runoff totals. Looking further on in the year into more of that non-frozen season, we also see May sticking out as typically having somewhat elevated total monthly runoff. I think these median values can be helpful for understanding sort of general trends that we expect to see, but it's also important to acknowledge that there's a lot of variation from year to year. So we're going to look at this variation, and I just want you to imagine that we're looking at this figure, but we've zoomed out. So here we have these little gray bars, and those are the height of those median values we were just looking at. But now we've zoomed out, so we have enough room to overlay the raw data that's going into that summary calculation. So here each dot is showing a measured total monthly runoff from a given site year. So we can see there's a lot of variation, from year to year and across different sites. And one thing that we've been thinking about in the past couple years is this seasonal pattern changing over time? And we really started thinking about this in 2024 when we had very mild winter conditions across the state with limited snow, but then a very wet May and June time period at the start of the growing season. And for our active sites that year, we had runoff in late winter, but not a ton. And really the bulk of our annual runoff happened more in that May, June time period. So we started to think about, are these changing winter conditions changing our expected seasonal patterns of runoff? And one quick way to start to look at this is to break down those points based on if they were collected, in the first 10 years of our monitoring program versus the second 10 years. So, older sites or more recent. So when we do this here, first we're looking at those early sites, and then we can overlay the more recent sites. And we see, maybe we are seeing some larger monthly runoff volumes from those recent monitoring sites, particularly more in that summer time period as well. So just a first cut at looking at this, and certainly something we're keeping an eye on and interested in continuing to explore further. But let's get back to those typical monthly patterns and talk about what's carried in that runoff water. So first we'll talk about soil losses. And we typically see the highest monthly soil losses in the month of May, and then to a lesser extent, June. And when we think about what our annual crop fields look like this time of year, there can be a fair amount of bare soil. The crop is in, but we don't yet have canopy closure to protect the soil, so it can be vulnerable to transport. And this is also a time of year in our state where we're starting to get more of our severe summer storms starting up. So this can create conditions where we see some elevated soil losses. Phosphorus has a somewhat different seasonal pattern where we see two key times of the year for elevated losses, so the months of March and May. And when we measure phosphorus in surface runoff, we look at two different chemical forms. So we can break down these typical total losses into the contributions of those two different forms. And when we do this, we see there's something a little different happening in March versus May. So in May, we have more of this particulate phosphorus. This is phosphorus we'd associate with being stuck to soil particles. And this makes sense with what we just saw for soil losses being highest in May. So we can infer that these elevated phosphorus losses in May are mostly due to this soil transport. March, on the other hand, has more of a contribution of dissolved phosphorus forms. So this is phosphorus that might be held in the soil, plant residues, recent fertility amendments, and it gets pulled into that runoff water solution, kind of like you would dissolve sugar in lemonade. So we can have dissolved phosphorus transport, even if we're not seeing a lot of soil loss. So in March, we can think that some of this is coming from the soil. It might also be linked to winter manure applications, but we'll talk about that in a bit more detail towards the end of the talk. So what have we learned from 20 years of this surface runoff monitoring? Well, a key piece has really been that this year-round automated monitoring has been essential for understanding, typical patterns of when we see runoff happening from Wisconsin cropland, the timing and magnitude of those losses. So understanding what's typical, but also how things can change from year to year. Some specifics. So for runoff, that late winter time is a key time for seeing runoff and potentially larger runoff volumes, but every year can be a little different depending on our seasonal and weather patterns. Soil loss, that late spring to early summer time period, is a critical time where soil can be more vulnerable to transport. And then for those phosphorus losses, two key times to think about. Again, that late spring time period with soil losses, and then also late winter in dissolved forms. You might notice that nitrogen is missing from this list, and that's because unless something unusual is happening at a site like a lot of soil loss or maybe a manure or fertilizer application shortly before runoff, we typically don't see a lot of nitrogen being transported in surface runoff. Just based on the chemistry of how that nutrient moves in soil and water, we more see that moving below the soil surface. So I thought it would be best to save nitrogen for our discussion of our tile monitoring. So we monitor tile in much the same way as we do surface runoff, with, of course, some small exceptions or some small differences. So obviously we have to access the water in the tile line rather than having it flow over the surface to the station. So we do this with an AgriDrain brand water level control structure. This is installed on the tile main shortly before the outflow. And we use a similar principle here to that surface runoff flume, where we continuously monitor the water depth in the upstream side of the AgriDrain and use that information to calculate drainage volume. These sites are set up with the same sort of automated water sample collection, and those water samples are analyzed for the same constituents as our surface sites, so we can make comparisons between the two. For the Wisconsin program, our monitoring is really focused on the northeast corner of the state. So this map shows a subset of our tile sites that I'll be sharing with you today. These are sites where we had that intensive USGS monitoring that we just saw on the last slide, and also where we didn't have any confounding interactions with shallow groundwater. So as you can see, we have a more limited tile data set. So I want to give a big thank you to the Minnesota program who graciously shared their tile data with me for this talk, just so we could expand our conversation. So this is just showing where their sites have been located across Minnesota, and adding a lot of site years of data to our discussion here. So we're going to be looking at a few figures that follow this setup. So we'll talk about a few components of this figure. Here we're comparing surface runoff on the left-hand side with tile drainage sites on the right. And the points here represent measured total annual either runoff or drainage for a given site year. And then we've color-coded the points based on what state the site is located in. So for surface runoff, we're only looking at our Wisconsin sites. And then for tile, it's a mix of Minnesota and Wisconsin. These points have been put over a box plot, which is just a tool to help us look at the distribution or spread of data points. So the box plot gives us the median or 50th percentile with that thick bar in the middle. So for our surface runoff sites, that median annual runoff volume is about 3.1 inches. And then for tile, it's 4.8. And then our box plot also gives us the 25th and 75th percentile with the bottom and top of that box. And throughout this portion of the talk, I'll be referring to this as our typical range. It's not the full range of observed values, but it's where half of our data falls within that range. So, comparing our surface and our tile sites here, we can see maybe a bit more water moving through those tile systems. And we don't see any obvious differences between Wisconsin and Minnesota. The Minnesota sites capture a wider range of annual drainage values. This makes sense since they have a larger data set, a broader geographic range. So they've captured, just more variation, and the Wisconsin sites are kind of falling in the middle there. But when we look within the year at seasonal patterns, we do see some differences between the two states. So here we're looking at average monthly tile flow, starting off just with Minnesota. And for these sites, we see a more typical pattern of tile flow where things start to pick up in spring and early summer with more flow. And then flow really tapers off in midsummer once the crop gets going and is using more water. And we usually see pretty limited flow during the fall and winter months. The Wisconsin sites, on the other hand, have more flow in the winter months. And the time where we see peak flows is shifted a couple months earlier than the Minnesota sites, so more in March and April compared to May and June for Minnesota. So likely some things here happening with differences in surficial geology between these two locations, and certainly something that we're interested in continuing to explore and try to understand. So that's the tile water itself. Let's talk next about what's carried in it, and we'll start with soil loss. So comparing our surface and our tile sites, we typically see greater soil losses in surface runoff compared to tile. But there are a couple exceptions here, and to get into this, we're going to zoom in on that tile panel on the right here. And when we do that, we see there are a few site years where we had higher soil losses, and mostly from our Wisconsin sites. So what's happening here is that tile material and maintenance are important for keeping soil out of the tile system. So here we have a subset of our Minnesota and Wisconsin tile sites that we've arranged from having sort of negligible to very low soil loss up to higher soil loss than we'd expect to see in a tile system. And when we start to look at some of the characteristics of these sites, we can see that those with lower losses were modern materials in good repair, and those sites that we're starting to see higher losses, maybe older materials, maybe some maintenance concerns, or having open surface inlets, which can be a way that surface runoff water carrying sediment can get into the tile. The two Wisconsin sites that had the highest sediment concentrations were clay tiles with an identified blowout during the monitoring period. So a blowout is another way that there's going to be this direct path from the surface into the tile, and it can be a way that a lot of sediment gets into the tile. So a blowout will happen when there's a weak spot in the drain that will eventually rupture. During high flow times, water is going to flow out of the tile into the surrounding soil, start to break off bits of soil, and then flow back into the tile during low flow. And then over time, this will continue to the point where the land above will collapse into that void space, and we'll have a tile blowout or a tile sinkhole. So this can, like I said, is a direct path from the surface into the tile, can introduce a lot of sediment into the tile system. Just a couple photos of also what these look like from the surface. So really important to inspect the tile systems annually, and if there are any issues, to address them promptly. Phosphorus in surface versus tile follows a similar pattern to what we just saw with soil, so typically seeing greater losses at our surface sites. But again, there are a couple exceptions here from our Wisconsin sites. So some of this might be linked to what we just saw with higher soil loss from some of those Wisconsin sites due to older materials or blowouts. But some of this might also be linked to higher soil test phosphorus at some of our Wisconsin sites compared to the Minnesota sites. And across our Wisconsin Discovery Farm sites, we see that there is this direct relationship between soil test phosphorus and the amount of dissolved phosphorus carried either in runoff water or in tile flow. So this could be a factor that's elevating some phosphorus losses at some of our Wisconsin sites. And again, something we're interested in continuing to explore. So at this point, comparing surface and tile sites, we've seen maybe a bit more water moving through those tile systems, but for the most part, less soil and phosphorus losses. And now when we get to nitrogen, this is where the story changes, and we typically see higher nitrogen losses at our tile sites compared to our surface sites. And we're no longer seeing sort of clear differences between our Minnesota and our Wisconsin sites. And when we think about nitrogen losses, the form here matters as we're most concerned about nitrate from a drinking water perspective. So on average, the total nitrogen losses at our tile sites are around 90% in that nitrate form, compared to just about a fifth at our surface sites. So I want to focus in a bit more specifically about those nitrate losses. So how much nitrate is lost will depend on flow and concentration, how much water is moving through the tile, and then how much nitrate is in that water. And there's a good relationship between flow and nitrate losses on a pounds per acre per year basis, such that we can expect for every inch of tile flow, we lose about between 4 and 4.5 pounds of nitrate. Now, the amount of flow, the amount of drainage we have is largely out of our control. It's going to be really dependent on weather and seasonal patterns, soil texture. But that concentration is a piece that's going to be more responsive to in-field management. And I just want to focus in on this part of the figure here, where we have a drainage value close to our annual median of 4.8 inches. And around that range, we have a range of nitrate losses ranging from about 10 pounds per acre per year to about 30 pounds per acre per year. And the magnitude of those nitrate losses depends on the concentration. So things that can lower that concentration are going to lower overall losses. So thinking about good in-field nitrogen management, right rate, timing can be a lever to help reduce those nitrate losses. So sort of a key piece here from some of our tile monitoring has been that tile will present different challenges and opportunities when it comes to water quality compared to our surface runoff. So on the soil and phosphorus side of things, it's possible to have very low losses in tile, but it's not a given. So it's important to have proper inspections and maintenance of the system, be careful with management around surface inlets, maybe considering something like a blind inlet as an alternative, and to follow nutrient recommendations on tiled land. For nitrogen, there are just some more inherent challenges for dealing with nitrogen losses in tile based on how this nutrient moves in soil and water. So really emphasizing the importance of in-field nitrogen management on tiled fields. But at the same time, tile also presents some opportunities for treating that drainage water that we would not have in an untiled system. So thinking about end of pipe practices like a bioreactor or a saturated buffer. Also, there's some interesting practices that have agronomic benefits, such as controlled drainage, which can alleviate some water stress during dry times of the year, but also reduce overall nitrate losses. Another key piece that we've learned from our tile monitoring is that we have more to learn about tile drainage in Wisconsin. So I just wanted to end this section here by highlighting a couple of our newer projects shown in the orange triangles here. So the first is a project studying a wood chip bioreactor to understand how this end of pipe practice works with Wisconsin's climate and cropping systems. And then we have two brand new sites in north central Wisconsin, so trying to expand our geographic understanding of tile in our state. So these are currently edge of field surface runoff monitoring stations on fields that do not have any tile drainage. We will monitor surface runoff for a couple years, and then both farms plan to install tile drainage on these fields. At what point we will have paired tile and surface monitoring. So this will give us information on surface runoff, soil and nutrient losses, both before and after the tiles put in. Just get a better understanding of potential water quality trade-offs with this practice. So it'll certainly be a while before we have results to share on that project, but we're very excited for it and stay tuned, I guess. So far, we've looked at a lot of observational monitoring data, and I wanted to close out this talk by sharing an example of how we can leverage some of this data to ask more specific questions about the effects of different management strategies for water quality. So I'll be sharing one case study, but just wanted to note that this was done in support of updates to Wisconsin's nutrient loss reduction strategy science assessment This is a huge body of work that a lot of people worked on. Our component is just a small piece of it. But if you're interested in learning more, that link and QR code has a general article explaining the effort. And the assessment itself will be published online soon, just not quite there yet. All right, but I'm going to share one case study in the time we have left. And this case study was focused on cropland manure applications, specifically looking at how the timing and application method might affect phosphorus being lost in surface runoff. So we addressed this question using our surface edge of field dataset and focusing in on sites that had cropland manure applications. So those are the sites that we use, circled in black there. It gave us 14 sites distributed across the state that were monitored between 2004 and 2024, and just over 670 runoff events that we could analyze. Our analysis goal was to understand if and how the phosphorus being lost in a given runoff event might be affected by the most recent manure application. So specifically how long it had been since manure was last applied, and then for that recent application, was it surface applied versus incorporated or injected, and was the soil frozen or not at the time of that application? And I just threw a couple photos in here of runoff happening at different times throughout the year and under different conditions, just to know that there's, other environmental factors that we need to take into account if we want to isolate the effect of these manure management pieces. So to do that, we used a statistical model as a tool to help us account for some of these other factors. So things that we accounted for included the amount of runoff. Was it just a little trickle or a big event? The timing of it, soil test phosphorus in the field, and then some information about the tillage program. So let's get into our results. And we'll start with the time since manure. So here we're just looking at the raw data before we get into those model results. Each point here is an individual runoff event that's been plotted based on how long it was since manure was last applied, and then how much phosphorus was lost in that given event on a pounds per acre basis. Looking here, we can see, maybe there's some greater phosphorus losses when it's been a shorter time since manure. There's a lot of variation here. So this is where the model is a helpful tool and can help us say, yes, there is a significant relationship, but the effect size is moderate. So we see each additional year since the last manure application associated with about 20% lower event total phosphorus losses. The next piece that we looked at was manure placement and sort of seasonality. So we compared winter applications to non-winter applications, and we saw that those winter applications were associated with higher P losses. So when we compared manure application surface applied on non-frozen soils, that was associated with about 30% lower total phosphorus losses compared to those winter applications. And then similarly for manure that was incorporated or injected, that was associated with about 36% lower phosphorus losses, again compared to winter applications. When we looked at both of our non-winter type of applications, we didn't see any significant difference in phosphorus losses for surface applied versus not. A couple things to note here. For those applications that were incorporated or injected, the majority were done with lower disturbance methods, so we wouldn't expect there to be a ton of soil disturbance from those applications. Also, many of our sites were at a lower risk of erosion just based on slope and soil type. So again, some of that disturbance from that application, we might not expect that, to be incorporated or to be associated with higher P losses. An interesting piece that came out of this analysis was that we saw soil test phosphorus was an important predictor of surface runoff P losses. So sites that had lower STP generally had lower event total phosphorus losses. So a couple key pieces that came out of this analysis were that manure timing and soil test phosphorus had the biggest influence on surface phosphorus losses. We saw greater phosphorus losses with less time between manure being applied and the next runoff event, as well as with those winter applications. We didn't see any clear differences with manure that was surface applied versus incorporated or injected when this was happening on non-frozen soil. And we did see a direct relationship, so higher soil test phosphorus being associated with higher P losses, So regardless of how manure is being applied, keeping an eye on STP and trying to avoid buildup is another good practice for minimizing P losses. All right, I think that's taken me to the end of my time. So I just want to wrap up here with a big thank you to the many people and organizations who make Wisconsin Discovery Farms work possible. And again, a big thank you to Tim and the Minnesota program for sharing their tile data. So I had a bit more to talk about for that. And with that, I'm going to hand things back over to Amber.
Awesome. Thanks, Ellen. Well, your presentation was a super success because we got questions already in the chat for you. So, um, uh, good to see Shalimar's with us today. Thanks for joining us. You covered a couple of the pieces of like manure application, Ellen. Do you quickly want to talk about the like tillage cover crop part of his question on for surface losses of dissolved reactive P, what were the impacts of tillage or cover crops?
Okay, great question. So for those particular models that I shared, we didn't see any significant effect of those tillage covariates that we had included. Um, and then we also did not specifically consider cover crop presences in that particular model. Uh, Part of that was due to data availability. So we only recently started quantifying our cover crop information at our sites in a more quantitative way. When the program started, none of our sites were using cover crops. As the practice became more common, we would include that in our management survey. Did you grow cover crop? Yes, no. Some more qualitative descriptions of how the cover crop did, but some of that's a bit subjective, so it's challenging to include that. So yeah, it would be great to dig into that in a bit more detail, but don't have a great answer for you at the moment.
Yep, continuing to work on that. Even after
Yes.
25 years, we still have
Yep.
questions. Right. Um,
Lifelong learners.
yeah, that's right. Eric Hurley's with us. Hey, Eric. At what soil test P do you start to see dissolved P losses in the tile lines?
So we can see dissolved P loss, and there's not like in our data, at least there's not a clear threshold of STP where we start to see, the presence of dissolved P or higher P concentrations. I know there's some work out of Ohio where they did see more of a break point around 80 to 90 parts per million for the Bray equivalent. In ours, at least above 30 or 40, we just see this direct relationship.
More
So
linear.
maybe perhaps if we had sites with lower, we'd see more of that break point, but in our data right now, we don't see sort of a clear threshold.
Awesome. All right. And then we have Mike with us. Thanks for joining, Mike. And so, nitrate loss in tiles, how much of that is attributed to soil type? He just mentioned he has seven different soil types in some of his fields.
Yeah, there's certainly a lot of surface or a lot of spatial variation in fields. I'm going to have to think about that a bit more. There's going to be some differences in terms of sort of the rate of water movement across different soil textures, and then also potentially different contributions from the soil itself when we think about mineralization of organic matter. So that could, come more into play with our finer textured soils or soils with more organic matter. But I'm going to keep thinking about that, Michael. So certainly, yeah, can keep talking about that.
Awesome. Well, thanks, Ellen, for that presentation. We appreciate your thoughtful approach to analysis and explaining that to all of that complicated information to us in a way that we can actually digest it. So thank you for that. All
Thank
right,
you.
so we're kicked off very successfully here. While we are moving to our partners in Vermont, I'm going to launch a quick poll. There we go. So this is anonymous information. It just helps us evaluate the audiences that we're reaching with this type of work. So it does really help us. And as a heads up, there will be a couple questions at the end of the webinar that asks you more about the value of your time with us today and what you learned from our presenters. So that self-rating is something we for sure look at and use to help us improve our future programs. And so if you can take a minute to answer that before you leave the webinar, we are super grateful for that too. Okay, so as you're finishing filling out that demographics poll, I'll go ahead and introduce our next speakers. So our next speakers will be from the Discovery Farms program in Vermont. Today we have Claire Benning and Dr. Heather Darby. Claire started working on the Discovery Acres project as a research specialist a year and a half ago, and she earned her master's in agroecology from UW-Madison, researching the benefits of cover cropping in organic dairy systems, and is currently pursuing a PhD in plant and soil science at UVM. Heather Darby is an agronomist and soil specialist with the University of Vermont Extension. She provides leadership on the crop and soil aspects of Discovery Farms research in Vermont. So the title of their talk today is Innovative Approaches to Addressing Nutrient Management and Water Quality Challenges in Vermont. So I'm not sure which one of you is going to talk first.
I think I'm going to talk first, but Claire, do you want to put up the slides and I can just have you move through them so we're not going back and forth?
Mm-hmm.
Great. Well, thanks everyone. Good to see great attendance on this webinar and happy to share with you what we've been doing here in Vermont. We are the newest member of the Discovery Farms program, so we don't have 25 years of data to share with you, but we wanted to share with you some of our first years of data and talk a little bit about why we got involved with this program and how it got started and what we're doing and hope to do in the future. So next slide, please. So like other discovery farms throughout the country, we have lots of partnership and stakeholder input, and that's been really important to our process. And so we have partners from different water quality organizations, nonprofits, USDA, conservation districts, and our agencies of agriculture and natural resources. So very similar to other Discovery Farm sites. Next slide.
And I can talk real quick. I can do this slide real quick, Heather,
Okay.
if you want me to do it.
Sure.
Just to orient us real quick to agriculture in Lake Champlain Basin. So we're a bit smaller over here compared to Wisconsin. The Lake Champlain Basin, where our research site is only 16% agricultural land. So if we look at this map here on the right, it's all of the yellow. So blue is our beautiful Lake Champlain, and all of the yellow surrounding that is our agricultural land. And it is primarily dairy farming here in Vermont, roughly 65% of our ag industry. And for our dairy farmers, a fall manure application is a very typical practice to meet plant nutrient requirements. However, this does overload our soils with phosphorus, and roughly 41% of total phosphorus loads to Lake Champlain is coming from agricultural production. And this has led to some seasonal harmful algae blooms since the 1970s, which is why some of our work is pretty important for water quality. And some of the challenges that the ag industry is facing in the Lake Champlain is really heavy clay soils, which are really poorly drained. This is a photo from our research site after a rainstorm event, where you can just see it's not percolating into the soil very well. So this is one of the reasons that we have a fall manure application, because of excessive moisture in the spring. And this increased heavy precipitation does increase flooding in our fields and decreases crop establishment and yields, and as well as leading to a loss of nutrients through runoff events. Legacy phosphorus is a primary driver of phosphorus loss in poorly drained soils with subsurface drainage, especially here in Vermont. And due to shifting climates, we are seeing periodic snowmelt in winter, as well as rain on snow events and shifting freeze-thaw cycles, which are increasing likelihood of nutrient losses during winter and early spring. As you saw from our folks in Wisconsin, that kind of March, early spring season is a really critical period for nutrient losses and soil losses. So those are some of the challenges driving our work here. Back to you, Heather.
Yeah, so as Claire was mentioning, we have where our predominant water quality issue does resolve around phosphorus and excess phosphorus moving into our local rivers and streams and surface waters. And so that's really the primary nutrient that we are trying to manage throughout our farms, especially those in the Lake Champlain Basin, where we do have EPA set TMDL for phosphorus. As a part of trying to manage the amount of phosphorus being lost and reduce the amount of phosphorus being lost into surface waters, the state of Vermont established new regulations in 2016 called the Required Agricultural Practices. And these are practices that are required of all farms in the state of Vermont. So those down to 4 acres, up to those farms that are considered CAFOs. So all farms in the state of Vermont must follow a set of required agricultural practices, including a whole variety of topics or a whole variety of practices around buffers and nutrient management, manure management, etc. Most recently, oops, next slide, please. In 2018, based on concerns of an increasing amount of subsurface tile drainage being installed in Vermont, particularly in the areas Claire was mentioning with the heavy clay soils. The RAPs were further amended to include language around addressing nutrient contributions from tile. So there are also now regulations around installing and managing tile drainage and the water that comes out of tile. Next slide. So that really was part of the desire, I would say, of both myself and Extension, as well as the farmers that I worked with. So in Vermont, we have several farmer organizations that are water quality driven. In particular, the Farmers Watershed Alliance, which is located in northern Vermont, is a group of farmers focused on improving water quality, reducing their impact on the environment while sustaining their businesses. And really, that organization has driven the work at Discovery Acres and really has driven accessing funding and the ability for us to do this work. And you can go to the next slide, please. I think I have one more. This has been really, really important because the farmers themselves are the people that want the research here. Of course, our regulators, policymakers, and people that work with farmers want to know how these practices that they're being required to install or being told they can't install, how they're actually impacting the quality of water and soil and crops in the state of Vermont. And that really is how our Discovery Farm site was started, out of the desire of the farming community to want to do better and to figure out how these practices that they're, again, being regulated around are truly impacting water and their farms. So with that, I'll turn it over to Claire to talk about some of our first results.
Amazing. So I will now orient us a little bit to our research project. So we have a paired watershed research project in St. Albans, Vermont with edge of field monitoring. And all of our water monitoring stations are in one field. So we have one field that has 4 natural watersheds that we are able to do this experiment on, and it was installed in 2020. We have 2 surface edge of field on non-tile drained land, our north surface and our south surface stations that have no tile drainage. And then we have 2 surface and 2 subsurface edge of field on tile drained land, our north tile and our south tile station. So we have back to back to back to back watersheds that we are able to collect water from and measure the effects of our management practices on. And we are comparing conventional management with BMPs on land, both with and without that tile drainage. So our conventional management practices are being done on our south watersheds, and that is going to be terminating cover crops with tillage and comparing that to a no-till cover crop planting in our north watersheds. And then in our manure management, our conventional practice is going to be a broadcast application in our south watersheds, and our best management practice is a manure injection in our north watersheds. And we're monitoring water quality, soil health, crop protection, and neonicotinoid pesticides. So this site was installed in 2020, and we collected calibration data from 2021 to 2022. In 2023, we started our transition year, and 2024 was our first full year of treatment data, with 2025 being our second year, this most recent year. So again, here are our 4 watersheds, no tile with conventional management, tile with conventional management being our 2 controls, and then our treatments being a tile and a no tile with best management practices. And again, our best management practices are doing a fall manure injection, no-till planting green with herbicide in the spring. So jumping into our weather and agronomic data from 2025. 2025 is this very light green bar right here. It was a bit of a dry year for us, especially during the growing season, compared to the 30-year average for St. Albans, Vermont. In addition to being a dry year, looking at the temperatures, it was a bit of a warm year as well during the growing season, with around a 1 to 5 degree departure from normal for our average temperature here in this top bar, or top boxes with our temperature, and then our precipitation is in this bottom 2 boxes, and you can see the decrease in precipitation during our growing season. To put that in perspective of our management practices, we terminated the cover crop in our control treatment in the middle of April, on April 14th, and we terminated the treatment cover crop with that no-till planting closer towards our corn planting date at the end of May. Corn was planted at 34,000 seeds per acre at the beginning of June. We did a top dress fertilizer application a few weeks later at 250 pounds per acre. Corn was then harvested towards the end of October, and we did our manure application and cover crop planting right after corn harvest. I would again just like to bring our attention to how dry it was for us this summer, and keep that in mind as we move throughout our data. Looking at our soil health data, we have our 2020 Cornell Assessment of Soil Health on the left, and our 2025 Cornell Assessment of Soil Health right here on the right. And we have our best management practice surface, best management practice tile, conventional surface, and conventional tile. And we're looking at the percent change, the green being increases and the red being decreases in the values from 2020. So something that is of note is that this field was coming out of 4 years of alfalfa and going into continuous corn. So coming out of 4 years of alfalfa, we would expect to see a decrease in soil health. However, we are seeing an overall increase in soil health in our best management practice surface, and the greatest decreases in soil health being in our tile drained plots, both in our best management practice and our conventional plots. Looking at our spring cover crop biomass production, there was a difference in biomass production by a great amount. It turns out when you let cover crops grow an extra month and a half, they really take the most, all that they can get. So there was substantial growth in our cover crop, no-till cover crop treatment in best management practices compared to our conventional treatment. Again, this was no-till planted. To give you an idea of what this looked like, this is at the beginning of May. The yellow on the right is the control conventional management, and the green is our no-till best management practices. And just a couple of weeks later, it was already lodging. By the time that we terminated it, I am 6 feet tall and it was up to my chest. It was just a very wet spring, and so we weren't able to get out there to terminate it and plant corn any earlier. And we did end up seeing this in our pre-side dress nitrate testing when we went out and took soil samples before applying fertilizer to the corn. So the cover crop that grew more took up more nitrate from the soil than the cover crop that grew less when we terminated it earlier. And we did also see that when the cover crop, we let it grow more, it affected our corn yields this year, with lower corn yields in our best management practices than in our conventional treatments. When we're looking at our corn yields, however, we also did corn stalk nitrate testing, and we saw that there was not enough nitrogen uptake to reach optimum yields in any of our treatments. And there was no real trend following the soil nitrate or the cover crop growth in our treatment or our control watersheds. Jumping into our water quality data, we're going to be looking at results from 2024 and 2025. 2024 was a little bit more of a wet year compared to 2025. So we're going to just be comparing both. The more the merrier. So in our red here, we have our summary of water sample events at Discovery Acres. What I want to bring our attention to is in 2025, in our conventional tile, we have tile surface station did have fewer surface station runoff events because of mechanical issues. And that is a bit reflected in our data, increased the variability a lot. So there are fewer surface runoff events from that station. And I would just like to remind everybody that our best management practice surface stations have only a surface station, and our tile treatments have a tile station and a surface station that we are collecting water from. And we are collecting water through surface station flumes, similar to what you saw at Wisconsin. We have auto samplers that are sampling water for us, and then we take them to a lab and assess them for nutrients. So here we have our average total nitrogen concentration split into 2024 on our left and 2025 on our right. And along the x-axis, we have our watersheds. The color scheme has switched a little bit here. So the blue is our surface stations and the red is our tile stations. So Here in 2024, we can see that tile stations had higher total nitrogen concentrations than our surface stations, regardless of being a best management practice or a conventional treatment. And we can see that that pattern held a little bit in 2025, but there was no statistical differences between the treatments. And when we look at load, so taking the concentrations and multiplying it by the amount of water that was flowing out of the system, we can see that the pattern kind of held and that the loads for nitrogen were higher in tile drain systems. And tile drainage had higher nitrogen losses than surface drain systems in 2024. That pattern held a little bit in 2025 in our conventional system, but there was extreme variability in our best management system. So there was, again, no statistical difference in our nitrogen loss. However, this is a little bit difficult to compare our total watersheds. So I added up the surface and the tile loads and compared the total nitrogen loss. And when we compare our total nitrogen loss, we can see that tile drained watersheds in both years have higher total nitrogen loss combined across surface and tile stations compared to watersheds that have no tile drainage in both best management practices and conventional systems in both years. However, in 2024, we can see that best management practices did decrease the amount of nitrogen being lost compared to conventional systems. If there wasn't as much variability, I wish we could say the same in 2025, but again, due to it being a drier year and some mechanical issues, the variability, we cannot say the same for 2025. Looking at total phosphorus now, we're back to looking at total phosphorus concentrations. In the blue, we have our surface stations, and the red, we have our tile stations, and we can see that it's a bit of a flipped story. So our phosphorus concentrations are lower in tile water draining from the systems than in surface water in both years. And when we look at total phosphorus loss, we're not seeing that tile is having any effect on reducing surface losses when we have tile installed. So comparing tile and surface stations, it's looking as though the surface runoff is similar when we have tile installed. And when we add up our total phosphorus losses across tile and surface stations, we unfortunately do not have any differences, or fortunately, do not have any differences between tile and conventional, or tile and surface stations and best management practices and conventional in 2024 or 2025, even though that it was a wetter year and a drier year. So we do not have any definitive results for total phosphorus losses there. So our next steps are to continue with treatment application and data collection. We are a much younger study design than Wisconsin, so we only have a couple of years of data under our belt. We're going to keep measuring crop productivity, water quality, and soil health. We're going to build a GLM for nutrient load data, and we're going to continue with a paired watershed analysis. In addition, we're going to add some new measurements, including carbon dioxide, methane, and nitrous oxide emissions. And if there are any questions, I or Heather would be happy to answer them.
Awesome. Thanks, Claire. It's fun to see things getting started and starting to see some of that data. Basically, what we have learned in Wisconsin is that when you have 1 year of data, you can say things. When you have 2 years of data, you can tell opposite stories. So
Yeah.
you're on the, I very much resonate with that feeling of like, well, I'm not sure what to say here.
And
Um,
there's such different years, so you can't
yeah.
even combine them to have a more powerful data set. And you're like, oh no.
It's the marathon, not a sprint.
Hmm.
So Sally has a question for you in the chat or in the Q&A. Did you look at soluble P versus total P as you'd expect this might be different in tiled systems?
I have not quite looked at soluble P versus total P. Um, I would expect those to be different. I have not looked at it yet, though. I
Okay.
have a, a ball pit of data that I'm jumping into. Um,
But we are
Yeah.
collecting.
yes, we are collecting it. We're collecting, yes, soluble reactive phosphorus, total phosphorus. Yes.
More to come on that. Okay, John has a question about lift stations at the outlets to help reduce nitrogen and phosphorus losses.
Heather?
You mean on the tile outlets, so opening and
Yeah.
closing, being able to open and close the outlets. They're not installed on these, but yes, that is a recommended practice now with new installation in Vermont. However, not all of our landscape is conducive for that type of um, management control. So that's all I can say about that. And other people may have be able to chime in, but it is recommended here if it fits within the landscape.
I know there's been a lot of questions about
Yeah,
lift stations in our recent tile programming in Wisconsin too.
yeah, yeah. We don't have them in ours.
Yeah. All right. Thank you, Claire. Thank you, Heather. That is what I have in the Q&A for now, but audience, you are welcome to continue to ask questions to any of the presenters, and we will have them cover those questions either in typing you a message back, or also we will might have time at the end to answer some more. So with that, we are going to go ahead and introduce our next speaker. Our next speaker is Tim Raditz. Tim works as the Discovery Farms Minnesota coordinator. His talk today is titled, What Do We Know About Edge of Field Water Quality on Wisconsin Farm, or sorry, Minnesota Farms. Um, Tim, I see your presenter mode, so there you go.
That better?
Yes, that's better.
All
Yep,
right.
good.
Thanks, Amber. As Amber said, my name is Tim Raditz. I organize the Discovery Farms program for the Minnesota Agricultural Water Resource Center. We are a nonprofit organization in Minnesota dedicated to helping farmers address water issues. And so one of our big projects that we do is Discovery Farms. And so today I'll be talking about Edgefield water quality and the Discovery Farms Minnesota program. And also, that was an interesting question from the last presentation on lift stations. We have worked with a number of lift stations, in particular up in Northwest Minnesota is where they're pretty common. They're typically installed where you don't have a good outlet and in really flat areas where it's harder to get outlets is where we find them. But they can be sort of managed like controlled drainage. So there can be some benefit to those stations. So interesting question. So as many others have covered, Discovery Farms is a farmer-led water quality research and educational program. All programs have the same three pillars: credible research, farmer leadership, and sharing the results. In Minnesota, our program has a steering committee comprised of farmers and conservation professionals, and this group guides the overall direction of the program, reviewing results and selecting new projects. One of our main partners is the Minnesota Department of Agriculture, or MDA, as I might refer to them in this presentation if I forget to say it all out loud. Their partnership, they collect and set up our water monitoring stations at the edge of the field. And so they're some of the leaders in our state in collecting this edge of field water research. And so their partnership is critical for us to have a high quality data source that we can use in education and outreach events. Funding for our program comes from a number of different sources. Our basis of funding is through the Minnesota Corn Growers Association. So not only are farmers leading with their voices in terms of determining what research is critical and what results matter, but they're also leading with their pocketbooks, right? They're funding a large majority of this program. We also receive funding from the Minnesota Clean Water Land and Legacy Amendment for monitoring equipment and Minnesota Department of Agriculture's involvement in our program. We also compete for other grants to expand our research areas. So just kind of to hit on this again, our program is really dependent on partnerships. Farmers are key. Department of Ag is key for setting up this monitoring equipment. We also partner with local soil and water conservation districts or watershed districts. And they're actually the ones that'll go out and maintain our monitoring sites, collect our samples, and make sure everything's running for us. We, as Minnesota Ag Water Resource Center, are the main education and outreach partners, and I touched a little bit before on what our organization is all about. So in Minnesota, we collect edge of field surface runoff data and tile drainage data every day of the year on real operating Minnesota farms. So this time period in particular, this March time period, can be fairly tough in terms of monitoring because of the fortunate cold weather or unfortunate cold weather that we get. Freezing is really hard on monitoring equipment and takes a lot of work to keep these things going. But it's a critical time period for our annual hydrologic budget. So really important that we collect that data to get a full picture. But we're looking at weather variables, whether it be soil, temperature, soil moisture, precipitation amounts, and then we're sampling the flow that either comes through the tile or over the soil surface through flumes, as Ellen showed before. And we're getting a volume measurement of that flow so we can tell how much flow, and then we're sampling that flow based on flow proportion sampling, sending it to the lab and getting results for sediment, nitrogen, and phosphorus. And also we have a website that's connected to our Discovery Farms homepage where you can go get real-time data for all the farms that we're currently collecting data on. This would be all the real-time weather data, and if water is flowing through tile or surface water runoff, it'll give you some information on the amount of water. And also at a number of our sites, we have real-time nitrate sensors installed, particularly in our tile sites. So that real-time nitrogen data or nitrate data is also posted on this website. So it is 2026. Where are we at now? The program started around 2010 or a little bit before. So we've been collecting data for 15 years now. We have a number of farms that we consider retired. So when we first started this program in Minnesota, our main goal was to canvass Minnesota and get good baseline information on what's currently happening with typical practices in Minnesota in terms of surface water losses or tile drainage losses, and look at very typical farming practices throughout Minnesota. And so Minnesota is a huge state, but also a very diverse state in terms of landscapes and farming practices. So as you move from the southeast up into the northwest, one of the cooler parts of my job is being able to see the different landscapes as we go through Minnesota here. Also, another cool part of my job has been working with different sorts of farming operations. We've worked with cash grain, we've worked with dairy, we're turkey, hog operations, beef operations. So just a very diverse set of agricultural enterprises that we've been able to work with as well. About 5 years ago, we've sort of tried to transition our program to, instead of looking at just generating some baseline data of what's currently happening throughout the state, we wanted to focus in on more specific practices. And we've done this with a couple paired basin projects and looking at cover crops and controlled drainage. And I'll touch on these at the end of the presentation, but that's sort of the direction we're headed. Is we have sort of a good idea of some baseline information in terms of surface water runoff and tile drainage. Now we want to look at specific practices to see what their impact on water quality will be. So the first part of this data overview will just look at some of our baseline or general information in terms of our canvassing the state for different types as the amount of runoff, looking at sediment, phosphorus, and nitrogen loss. So these next few charts will summarize all the data that we have collected over the years. This slide focuses on water volume leaving through either surface runoff in the orange or tile drainage in the blue. This chart depicts annual runoff in box plots. Ellen touched on these a little bit before, but the important part is that colored box represents the 25th to 75th percentile. The X in the middle represents the average. And so when I talk to our farmers and educate and provide some outreach on this data set, I typically think that our colored boxes is kind of what we would expect. It's kind of an expected number that really wouldn't surprise us if we set up monitoring on somebody's farm. So for tile drainage, anywhere from 2 to 8 inches of tile drainage on an annual basis. And for surface water runoff, anywhere from 1 to 3 inches on an annual basis. So on average, we see about 2.5 times as much water leave the field through tile drainage compared to surface runoff. If we compare this to the amount of precipitation that the field collects, this adds up to about 23% of the precipitation leaving the field. So 17% of the precipitation leaves through tile drainage and 6% leaves through surface water runoff. So another way to look at this is our farm fields that we've monitored on average retain 77% of the precipitation that we're monitoring. So there's a difference in the amount of water in terms of volume. There's also a difference in timing of when that water moves. For surface water runoff, we're pretty evenly split through frozen and non-frozen. And in frozen, we typically think of as snowmelt runoff. It's just the period that we're coming out of right now. And in any given year, depending on the year, we've monitored that has been 100% of our water budget for the entire year, and some years it's 0. So it really moves back and forth, but overall on the average, we're about 50-50. When we look at tile drainage, we're primarily looking at the growing season. We don't see a whole lot of flow during that frozen ground period in Minnesota. If we dig into this further, the timing of runoff, looking at average monthly runoff or tile drainage, we can see most of our activity is happening in that March through July time period. So 84% of our surface runoff is in the period we're just entering now, and 75% of the tile drainage. So it seems to be after we move through this early spring, early summer time period, when our crops become more canopied, they're using more water, we have less water to monitor. Also, a difference between our surface and tile is our runoff duration. So although we get more volume through the tile, we also get a much longer duration. So a duration would be just adding up all the minutes throughout the year that our sites are moving water. So on average, our tile sites are moving water 167 days per year. Correspondingly, if we're looking at surface water runoff, we're moving all of that water in just 7 days per year. So you can see there's going to be a difference in intensity if we're looking at the comparison of surface runoff and tile drainage. And just to kind of hammer this point home a little bit, this would be our Dodge County site in 2015 and displaying the hydrograph for an entire year. And so our blue is our surface water runoff. So you can see those peaks there. And you can see the tile is in orange, much lower peaks, but much more consistent flow throughout the year. So in 2015, we had 30 inches of precipitation, so pretty dry year for this area. We had 1.7 inches of tile flow compared to only 0.8 inches of surface water runoff. But if we look at our peak discharge for tile, 1.2 CFS compared to 2.72 CFS. So much lower peak discharges, even though we're moving more water. So for tile flow, a less intense flow compared to surface water runoff. In 2019, a much higher rainfall amount. This is one of the wettest years we've ever monitored throughout our Discovery Farms network. 53 inches of rain. Tile flow, almost 12 inches compared to 5 inches of surface water runoff. So we run that 2 to 2.5 times more tile flow. But if we're looking at our peak discharge of 0.36 versus 0.8 or versus 8.2 CF, 8.62 CFS, excuse me, you can see there's just the surface water runoff is just a lot more variable, a lot more flashy, and has much higher peak discharges. If we're looking at soil loss, this chart depicts annual soil loss for surface runoff and tile drainage. As you can see in the graph, most of our soil loss moves through surface water runoff. And by our averages, 17 for tile drainage compared to 278 for our surface water runoff, with some very high annual years where we saw elevated amounts. So a very skewed data set, I would say. And this primarily happens during the growing season. And in fact, May and June is really the period that we're looking at. And almost 70% comes during May and June. What happens during May and June is a combination of vulnerable or bare soils and more intense rainfall events. So what this tells me is that if we want to reduce soil loss, we need to focus on providing soil protection during the months of May and June. And this can be the most challenging time to provide that protection if we're growing annual crops. But it can be done with reduced tillage, increased residue, or trying cover crops, and perennial crops obviously will provide more soil protection during this time. Moving on to phosphorus loss, this chart depicts total phosphorus loss on an annual basis throughout our program. We also see most of the phosphorus movement through surface water runoff compared to tile drainage. And our surface losses are split between frozen or snowmelt and the growing season, about 40% during snowmelt and 60% during the growing season. What's unique and challenging about phosphorus movement is that about half of it is attached to soil particles, and about half of it is attached or just as dissolved phosphorus in the water that is moving. And traditionally is thought most phosphorus movement is attached to soil particles, and a lot of our conservation practices that reduce soil loss also reduce that particulate phosphorus. But corresponding, some of that doesn't translate to dissolved phosphorus. So I think some of the talks before have touched on this, but what we really see as important in Minnesota is if you can incorporate phosphorus from fertilizers and manures into the soil profile without increasing your soil loss risk, that's going to give you your best chance of reducing overall phosphorus losses. All right, on to nitrogen losses. This is where the story shifts from soil and phosphorus. This graph depicts total nitrogen on an annual basis throughout our program. As you can see, most of the nitrogen loss that we observe is through tile drainage. This makes sense as nitrate nitrogen is negatively charged, and it moves freely with water. As water infiltrates the soil profile and moves to our tile, nitrate can move freely with that water. Most of this happens during the growing season, which is pretty typical, is almost the same fraction when we're looking at when tile flow happens. And over about 94% of that nitrogen in our tile is in the nitrate nitrogen form. So when we're looking at nitrogen movement in our farm fields, we're really focusing in on tile drainage, and we're really focusing in on nitrate movement. And in fact, you get a pretty good relationship if you plot up the amount of tile drainage versus nitrate loss. The amount of nitrate loss is heavily dependent on the amount of drainage. So for every inch of drainage that we get, there's about 4 pounds per acre of nitrate loss. What's interesting about this is while tile drainage is pretty heavily linked to how much precipitation you get in any given year, so we don't really have a whole lot of control. We can do some things like controlled drainage or other practices that may reduce this drainage amount. But really what we have an impact on is the concentration of nitrate that's moving with that tile drainage. So whether it be through our 4R practices of fertilizer and manure stewardship, looking at, timing and rates of application, that can have a big impact on the concentration of nitrate in that water. So say our typical average loss is around 6 inches of drainage in any given year. Well, our nitrate losses can shift from 10 to 40 pounds per acre, just dependent on the amount of nitrate that you have in that soil profile. So we can have a big impact on the amount of nitrate movement just with proper nitrogen management practices. If we look at combined contributions, we've had a number of sites. I think it's 5 or 6, and it's probably up to 7 now, where we've monitored surface water runoff and tile drainage on the same field, where we're looking at the same drainage area. So kind of looking at averages on these sites for combined runoff, we see about 75% of our amount of water leaving the field comes through tile compared to surface water runoff. However, TSS, 95%. And TSS is a measure of sediment loss. Phosphorus loss, 84% through surface water runoff, 77% for dissolved phosphorus. And then again, that story flips when we move on to nitrate and nitrogen movement, where we're looking at 95% of our nitrate movement we observe through our tile lines. So just kind of overall, if we're looking at what, a lot of people ask me, what's the best practice? Well, it really depends on where you're located, what farming system you have, and really what constituent you're looking at. What's your most important water quality issue that you're trying to improve. So using that as our basis of water quality data, we moved into looking at specific practices and how their impacts are going to, and what their impacts are going to be on water quality. So one of our sites that we first started doing this at would be our site in Redwood County, Minnesota. This is corn soybean territory in southern Minnesota. So pretty typical sort of cropping rotation of corn followed by soybean. We have 2 sites in this one field, and we set up a paired basin study design. So we have a north and a south basin. So from 2017 through 2020, both were managed the exact same. They both had a corn soybean rotation, no-till the beans, spring vertical till the corn, fall anhydrous source for the corn, and then cover crop flown in August. During that period, the farmer had some real learning experiences in terms of flying on cover crops and what actually works and what doesn't. And he pretty much found that the only thing, the challenge in Minnesota and in northern climates with full season corn and soybean rotations is getting cover crops established. And I'll show you some pictures in the following slides. Where he had the most success in getting those established was just with cereal rye. Um, and and some of the other cover crops that are promoted in terms of type of crop, he just had very limited success with getting that to grow. So the change happened in 2021, where cover crops were flown on the north site, which would be the blue site up here. He actually ended up going towards um, drilling the cover crops, moving away from flying them on, drilling them right after harvest on the north site, but not the south site. And all other management variables continued the same way, besides that one change in practice. And so if we look at fall cover crop growth, this is where, it gets interesting. And most of these pictures look like a complete fail. If I was looking at a cover crop study, it'd go, there's no cover crop here. You can see some green poking out in the fall of 2020 and the fall of 2023. Otherwise, very limited growth. However, if we move into spring, we can see some more growth. And these were measurements taken before termination. And you can see some years we got some, pretty good green growth, but our high in terms of biomass was 615 dry biomass pounds per acre. So I think some people that grow a lot of cover crops and have more of a fall period to grow cover crops might look at this and see a total failure, or question the worth of doing this practice if this is the limited growth we're going to see. And I guess I was one of those people as well. I was really, really curious as to see what sort of impact we could have on water quality with the limited amount of cover crop growth we could get in this climate with this cropping system. And we did observe no differences in surface water runoff, sediment, or phosphorus loss. And my thoughts too on why this is, maybe due to a lack of cover crop growth. It's just a limitation of this area and this sort of cropping practice. I think also the episodic nature of surface water runoff and correspondingly soil and phosphorus loss, because that's where we see most of our soil and phosphorus loss. As I showed in some of those hydrographs, it's really high peak flows, but happens very infrequently during the year. So if our cover crop was in place but not growing when our surface runoff was occurring, for example, May and June, we're not going to have much impact on our surface runoff, sediment, and phosphorus loss. There's also some questions with dissolved P in terms of there's some studies out of Canada, which we're close to Canada. So questions on if we're having, some worse impact on dissolved phosphorus loss. We did not observe any difference in dissolved phosphorus loss, but that was one of the questions we're looking at. However, the cool part of this study, we did see some pretty major impacts to nitrogen movement or nitrate movement, which I was very happy to see with our limited cover crop growth. So this would be a chart depicting all our samples for from 2017 through 2025. This period on the left would be our calibration phase, and this period on the right would be our treatment phase. What I think is fascinating for this study is you can see all of the blue would be our north site, the south would be the red would be our south site. During our calibration phase, these sites paired up very well. There was very little difference between concentrations. And as we moved into our treatment phase, that sort of remained the same. But and this was concerning to me as I was first looking at this data in 2021 and 2022. But as we moved in further into the treatment phase, you can see there's a big difference in the flow weighted mean concentrations, but just also the sample concentrations. And in fact, in 2025, you can see just a very distinct difference in terms of the clusters of our nitrate sample concentrations. So we're having a pretty major impact on nitrate concentrations in our tile lines. And so I was hoping the paired basin statistics would bear that out. If we're looking at just our concentration differences between the calibration phase and the treatment phase, we see very little difference between the north and south basins during that calibration phase. Very little difference in that first year of the treatment phase, but I think there was some sort of delayed impact due to the cover crops. And from 2022 to 2025, we saw pretty major differences in our nitrate concentrations. So, based on our paired basin statistics, we found significant trends in the intercept for tile flow. So, we're actually reducing the amount of tile flow due to the cover crop, a 45% reduction based on the statistics. If we're looking at nitrogen yield or nitrate yield, excuse me, we see a significant trend in the reduction of nitrate yield and a significant trend in a reduction of the flow weighted mean concentration. So reducing concentration and reducing flow will correspondingly lead to reducing that yield or the pounds per acre number. So I was very excited to see the results of this study. And I guess my take home message and what I've been talking to people about is, if we can get rye or some sort of crop that is very hardy, just planted after harvest, even if we don't see much growth, if we see some limited growth in the spring, we could, and in this study shows that was having a significant impact on nitrogen movement. But we could have, even if we're not seeing that growth with our eyes, we might be having some impact on nitrogen movement. So that's very, very exciting to me. We're also looking at controlled drainage in terms of a conservation practice where we could, limit the amount of tile flow during certain time periods, and corresponding with that, limit the amount of nutrients that move with that tile flow. So we have a project in Waseca County, which is southern Minnesota, at our Farm America location. And this is new tile installed with controlled drainage in mind. So we have 4 different plots on this field, 80-acre field. And so we can either control any of these plots or not control any of them. We're just moving out of the baseline phase and moving into the treatment phase, where we're going to control one of the northern plots and one of the southern plots and not control the others to get a handle on what sort of impact we can have on tile water quality. So it's just a picture depicting conventional drainage versus controlled drainage. We can raise and lower the outlet elevation by adding or subtracting gates. So you can manipulate that water table throughout the year. So the idea is in spring to lower that water table to plant, raise it in the early summer and summer so that the crops can use it, lower it during harvest in the fall or early fall, and then raise it all the way up through the late fall, through winter months. So throughout the year, we have a controlled drainage management plan that we can alter water table levels, which is kind of cool. So other ideas. So I would say 90% of the information we get asked about is tile drainage. Tile drainage is a very hot topic in Minnesota. A lot of questions on tile drainage and how tile drainage works and what it's doing to our flooding impacts or what it's doing to nitrogen losses. So most of our ideas are working at more information on cover crops and how they're impacting tile drainage and water quality on tile drainage system. Also looking for more information on alternative cropping systems, saturated buffers, bioreactors, and I really like to get into drainage water recycling, where we're, draining during times of the year where we need to drain, and maybe collecting that water and reuse during times of the year where we would need it. So with that, Amber, I'll take any questions that might have come up.
Yes.
If there's time.
Yeah, I think we have time for a couple, and there are some here. So let's see. I think some of these you maybe did cover, but maybe we'll just kind of go through and remind. So cover crop growth impacting runoff. So with your tile drainage discharge numbers. Was that the 45% reduction?
Yeah.
Yeah. Yep.
Yep.
Yeah. All right. So 45, you saw a 45% reduction in drainage
And
so
in the
far.
amount of drainage, just in terms of when that cover crop was growing in the spring, it was utilizing water in that soil profile. So that's where we saw the difference.
Right, perfect. Have you broken the nitrogen drainage losses into cash grain versus veggie versus dairy?
I have looked at that. I would say, in terms of if you're breaking it up by timing of nitrogen application, either manure, fertilizer, or if you're in veggies, there might be different times of the year where you're applying to, but also rate. So if you're comparing everything on those, I don't think there's a difference in terms of nitrogen source. It's more dependent on management of that nitrogen, whether it would be commercial fertilizer or manure.
Okay, yes. And then do you have a comment about Mark's question or Mark's comment here on the like pounds per acre loss? I mean, I think that, one of the things that both you and Ellen did a good job talking about was that like we can control the concentration. We can't
Mhm.
necessarily control the amount of runoff, but the concentration there. And it looks like you did have some success seeing a decrease in concentration with rye. And also wondering if you wanted to comment on this question of like um, the how you approach the similarities and differences between tile and ground, kind of like the groundwater standards.
Yes, it's a good question. So I hesitate to compare tile water to drinking water standards because I don't recommend anybody to drink tile water. And if we're looking at tile nitrate concentrations, anywhere from 10 to 20 parts per million or milligrams per liter is pretty standard for tile water. That when I work with farmers, if we can get in that range, I tell them that they're doing a great job because they are based on the data I've seen. Um, the question in my mind is with cover crops or these other practices, could we get down to 10? Possibly. I don't know that it would meet the standard. But again, I don't think that's a great target to be looking at. The spots where I'm really looking at working with farmers are when we get into the 20s or 30s or 40s, or I mean, sorry, excuse me, 30s, 40s, or 50s of milligrams per liter, parts per million in terms of nitrate concentrations in our tiles. Then I believe we have some room to work on nitrogen management in terms of timing, product rate, whatever it is. There's some wiggle room there that we can definitely make improvements.
Awesome. Thank you for answering that. Sally's got a question about bioreactors. Have you considered bioreactors? I know you have some experience with them in Minnesota, and I don't know if Ellen wants to talk about some of the initial understanding from Wisconsin, and the benefits and challenges.
Yeah, we have worked with bioreactors in the past and are still willing to get more data on that practice. And they do work phenomenally well for the water that you can move through them. You'll get very big nitrate reduction rates in terms of water coming in and water going out. The issue I see with some of them or the limitations, I would say, particularly in a colder climate. So they work better because of the bacteria work better with higher temperatures. So in colder climates, they don't work quite as well. But um, the main limitation to that practice that I see is the amount of water that you can push through those. So if you can only treat 10% of your water throughout the year, you're only getting that impact. If we can increase the amount of water that we can treat with bioreactors throughout the year, I think you can do a better job overall of reducing that loss.
Ellen, I saw you came on camera. Did you want to have any comments on that from Wisconsin?
I feel like Tim did a great job. So I don't have too much to add. Just that I think there are maybe 3 wood chip bioreactors in the state of Wisconsin that I know about. So, we just have sort of a limited population of these things to be studied and getting information on. So still a lot to learn.
All right, Tim. So last question that came for you from Michael was the difference in NRP loss by type of cover crop, termination, timing height. So a lot of questions about the like cover crop specifics. Is there anything else you want to say about that?
Yeah, unfortunately, we only have the one study that was only looking at a winter rye cover crop, so don't really have information. But I would just say, in terms of looking at our climates and a full season corn soybean rotation, I don't know that the type of cover crop really matters all that much. I think the most important part is getting something that would provide some growth in the spring. So that would be the main difference.
Yeah, that's pretty similar to what we talk about in Wisconsin, which is just that we see the most benefits from something that will overwinter. And
Correct.
we do have a lot more corn silage in Wisconsin, which is a really good opportunity to establish something that will overwinter and give you those spring and like
Yeah,
off-season benefits.
yeah, I would say corn silage or things that you have a longer fall time period is really the time to experiment with different cover crops and look at different mixes or types of crops that might give you different benefits.
Perfect. Well, thank you for that. It's awesome to see the all the different pieces that Minnesota's been able to put together over the years too. So, for our last but certainly not least presentation of the day, we're traveling south for a session from Discovery Farms Arkansas program and Dr. Mike Daniels. Mike is a distinguished professor in soil and water conservation at Arkansas Division of Agriculture Cooperative Extension Service, and he's the co-leader of Arkansas's Discovery Farms program. His talk today will be monitoring nutrient losses in runoff from poultry litter applications in rice production. All right, Mike, it looks like, do you want to do presentation view there?
Yeah, I'm looking for it. I had it set up and I pushed something and lost it.
I think.
Uh yeah, let me go back to my uh
If you
oh,
go
it's
up to
paused.
slide.
Let me reload it.
Okay.
Okay. Whoops. Share. I just want to share. Okay. How's that? Is that better?
Still loading. Okay, so now if you go up to slideshow,
Yes. Well, I, I've got a bar in the way. Let me see if I can.
oh,
Here we go. Now I got it. Did I get it there?
um,
I'm not at my office. I'm at my son and daughter-in-law's house, and you wouldn't believe how much confusion that's causing me.
well, it's too many things going on at once. Yeah, so from beginning, there you
There
go.
we go. Can you
Yeah,
hear me okay?
I can hear you great, and this looks like it's in the right mode, so I'm gonna let you have the show.
Okay, well, thank you, Amber. It's always a pleasure to do this four-state Discovery Farm webinar. I missed it last year. I think James Burke filled in for me. We just finished up a project where we were specifically looking at the use of poultry litter and row crops. And I'll explain a little bit more about that. But I want to get a shout out to some of our Discovery Farm team members. This project was really spearheaded by Eric Simon, who I think was on earlier, but others contributed to it. Lee Riley, Jace Clark, Brett Cooper, Grant Bennett. So we've had a lot of different people work on this project, but we really NRCS realized that we had two new poultry integrators that had moved into the state, and it was making poultry litter much more. Before I get to that part, let me just I noticed that everybody's done this, so I wanted to do it up front. but these are some of our sponsors. These are some of the people that have invested in our program. We really have no budget, so we have to go out and, find grant money to do the things that we do. And actually, it's not been as hard as I thought it might be, because a lot of people are interested in the Discovery Farm concept and what we're doing. But I wanted to thank these different groups. As I was saying, though, we have for a long time, we have recommended poultry litter on row crops, but for the longest time, it was just strictly to correct low productivity on land leveled soils. Now, let me tell you something about watching the three previous. We don't do any tile drainage in Arkansas. Our soils in eastern Arkansas are pedogenically formed and also through compaction. We have some very restrictive soil layers that are very restricted to vertical flow, such that they maybe only be 4 inches below the surface. And that tends to make most of our soils in eastern Arkansas poorly drained to somewhat poorly drained. And when they get wet, they're going to stay wet a while. And so what we do instead of doing tile drainage, when you have a vertically restricted flow at 4 inches, you can't bury tile drain and expect to get water to it. And so we do land leveling. This is a 449 practice approved by NRCS. But we basically go in and through a process of cutting and filling the soil, we create a uniform grade on the surface. And I'll talk a little bit more about that in a minute, but that allows us to have a uniform slope and water to move from the top to the bottom of that field. It's not only for irrigation, it's also for removing water. So that's our drainage, is irrigation land leveling. And what happens though is sometimes when you land level, you may be removing as much as 2, and in this case of this study, I'm going to show you up to 8 feet of soil from the soil surface, redepositing that in low spots so that you get this uniform slope. And what we've found over the years is when you remove all that biological activity from the top few inches of the soil, we've seen rice fields that were low in production for 20 years after land leveling. And the one thing that we found to work on it was poultry litter. And we didn't always know the mechanism, but it's not necessarily just the nutrients that poultry litter provide, because we could add the same amount of our nutrient equivalent through commercial fertilizer and still see low production. It's something about restoring the physical and biological properties of that soil that poultry litter has been doing. Poultry litter is often used by our row crop farmers when commercial fertilizer prices are high. And right now we're in a very high period of commercial fertilizer prices. You cannot find poultry litter right now. It's all been accounted for. We've always said it would be a good fertilizer in eastern Arkansas, but most of our poultry production was in the western side of the state. And really, you just couldn't pay the transportation costs because you still got a moisture content of about 30%. And anytime you start hauling water, you know that the transportation costs are going to eat you up in terms of getting it shipped across the state. And really, when you look at our state, we're divided into 3 different extension regions. The red region is known as the Ozark. That's where the Ozark Mountains are at. That's primarily cattle and poultry. And then you come down to the blue part, that's the Ouachita district. Ouachita Mountains are there. In the southern part, we have our coastal plain soils, very sandy, primarily timberland, but we do have cattle and poultry mixed in there. And if you look at the counties in green, this is part of the Arkansas Delta, as the Arkansas River, the Mississippi River borders Arkansas. And so this Mississippi River Delta is this area, very flat, very productive soils, very deep soils, except we do have that zone that reduces water flow vertically, which allows us to grow rice and use less water doing it. And so this is where our row crops are at. And you see the problems over in western Arkansas, Benton, Washington, Madison, on down this western, trying to get it across the state to put on. But we've had new integrators come in, and we've got farmers now growing poultry in these fringe counties here between the red and the green. And all of a sudden, our row crop farmers have easy and affordable access to poultry litter, they started using it up in these counties in northeast Arkansas. And we just felt like, if you followed Arkansas in our history, this area up here in northwest Arkansas has had two major lawsuits about use of poultry litter flowing into Oklahoma. Uh, and we wanted to try to avoid that same thing in northeastern Arkansas. Even though different crop, different land use, still there are concerns about using poultry litter. This tends to be put on higher slopes in eastern Arkansas. We engineer these slopes on land level fields to be about a tenth of inch of fall, so not very big slope at all. So these new integrators are much closer, but we have two natural resource concerns. And believe it or not, our farmers are very interested in our natural resources in north central Arkansas. This is my son back when he was a teenager. He's now married, going to have their second child anytime now. And my dad, so it's generational. This is fishing, trout fishing on the White River. Uh, and many of our farmers trout fish. They want to protect this. They also want to make a living. And I think we can do both. But our natural resource concerns obviously are water quality with the use of poultry litter, and then exacerbating that, and what we found in northwest Arkansas is building up phosphorus from repetitive annual applications of poultry litter. But on the other hand, we all the focus on soil health, and you heard about soil health from Claire and some of their indicators. We think poultry litter can increase soil health in eastern Arkansas and some of the indicators. And I'll talk a little bit about that, but I'm not going to share all of our data on that today. I'm going to focus primarily on the water quality. So thanks to funding from NRCS and from the EPA Farmer to Farmer, we were able to establish what we call a row crop poultry litter farm and the Discovery Farm in Jackson County, which is right up here in that area where we're getting a concentration of poultry production. We also established two more farms. We didn't have enough money in the grant to do the monitoring there, but we did track and look at the soil health and the soil test properties year after year of applying poultry litter as fertilizer in Lawrence County and Greene County. And that was just to see if we were building up soil test phosphorus. We utilize edge of field monitoring to determine water quality impacts from different rates of poultry litter on rice. There is some compounding in that. Sometimes when you go on real farms, you can have some compounding. I'll talk about that a little bit more in a minute. We conducted annual grid sampling on 11 fields to track phosphorus buildup in soils. And then we monitored selected soil health parameters. We used the soil aggregate stability. And one thing we found is that wet aggregate stability, we see an increase in soil health quicker in this one particular indicator than we do some of the other. We did initially start some soil microbiological activity. We thought we would see differences in the biological activity due to the differences in the rates of poultry litter, but we did not see that. So we weren't as smart as we thought we were on that. And I'll talk a little bit about organic matter. We have a hard time building organic matter in our soils, and I'll talk a little bit more about that in a minute. But I want to share some of the results we found from 2021 to 2024 on the Dennis Haywood Farm. The Haywood Farm is actually three brothers, and then two of their sons, so two cousins. So five farmers, but they farm 14,000 acres of cotton, rice, soybeans, and corn. And they're tremendous cooperators. The soil types are Amagon and Forestdale silt loams. They're silt loams at the surfaces, but again, they're some of these soils, as you get farther from the White River, are more suitable for rice. Some of them are very sandy right next to the river because those soils formed by the sediment, the sand dropping out quicker when those fields flooded. We still have a problem with flooding at this site. We've had to go get our equipment out of the field because it was going to top over our samplers. And so we knew that risk going in, but they also had just freshly land leveled or had plans to freshly land level 3 fields. And we had to take advantage of that opportunity to look at we really wanted to see if we could understand the improvement in soil health after land leveling. And some of their cuts were 8 feet deep. And so The field history, these were dryland fields. They wanted to land level so that they could irrigate them. Uh, these fields do get river overflow though, but not usually during the growing season, but at times when we can flooding. We did have one event early in the spring or late winter that it went over 26 feet, and they called us and said you better come get your equipment. But the following year we got hit by a tornado, and one of our samplers probably ended up in Missouri. We never did find it. So we could. Oh, hold on just a second. Oh, that's all right. That was my grand dog Brody making his appearance. Came in through the doggy door. But anyway, they started agricultural production in this site in 1954. Once they removed and did the 10th grade land leveling, so 1/10 for every 100 feet is our slope. Just enough to help gravity move water, but still very, very flat. And that to restore that, they looked at the poultry litter application, and that's where we came in, and we found them as cooperators because we knew they were going to be adding poultry litter, and it gave us a good situation. But like I said, in all farm, and I'll talk about it a little bit more in a minute. The first thing we did though is that we had them go ahead and do litter testing. A lot of our row crop farmers are new to poultry litter. They're not doing litter testing. They're just buying the litter and putting it out. And the one thing that we found is that there can be variability. Now, in these batches on the Haywood's farm, there was some variability. And really, we don't need to be talking about putting it out, even though we designed our study to be 2 tons, 3 tons, and 4 tons. We really need to be talking about in terms of crop nutrient needs and best match those. As you know, poultry litter is not a balanced fertilizer because a lot of the nitrogen you see in there, that content's going to be lost to volatilization. And so we can put as much phosphorus out as we're putting out nitrogen, and the crops just don't need it as much. And I'll talk a little bit more about that in a minute. But you see there's some variation and some differences in the nutrients, but still our treatments did over the time show, some differences in the amount of nutrients we were applying over those times. I wanted to show you another farm though we retracted just to show you the type of variability that we're dealing with in this poultry litter. I mean, we had one batch, 15 pounds of nitrogen per ton, all the way up to 55. And then we had phosphorus, highly, highly variable. We went from 28 pounds up to 71 pounds. So if you're not getting your litter tested, even if you're getting it from the same farm, you don't have any idea what you're putting out in terms of nitrogen, P2O5 and K2O. Now, one of the problems that we have with nitrogen with poultry litter is that we can get volatilization, but our springs can be very warm and wet. And when you get warm, saturated soils, we know what can happen to nitrogen. We can get a lot of denitrification. And so we really don't know sometimes on the nitrogen, and it makes it tough. So our guys are very leery of replacing commercial fertilizer with poultry litter. They may on their phosphorus and potassium, but nitrogen, they're still going to put their nitrogen out for fear of being lost or not available through the poultry litter. And those are some things we're going to have to work through because we've got to make sure that we're putting these out in a manner that's not going to be cause a natural resource concern. Now, these are the 3 fields. This upper field, the north field, we called Hague 3, and this one got 4 tons of litter. But it's also a row rice field. And what I mean by that is they don't flood these fields like in typical rice production. They're trying to save water, and they're thinking, hey, if we just keep those soils wet through furrow irrigation, we may not use as much water as trying to maintain a flood on these bottom 2 fields, like you typically would in a rice production system. And so, but here's the confounding problem. Anything runoff that leaves this upper field goes into this middle field. And so they are kind of connected that way. We have not correct the data I'm going to show you. We have not corrected for what's going into the other field. We just simply were looking at what was coming out the bottom of this field and then the bottom of this field. Um, and this middle field got 3 tons per acre. The south field got 4 tons, and that's kind of a high application rate. But we felt like from a water quality standpoint, we wanted to kind of push the limits. We wanted to see, are we going to see big differences out there because of that? It's been rice ever since they land leveled it. It'll be rice for several more years, and then eventually it'll start working in soybeans and corn into the rotation. But for right now, it's rice because rice is uh, does the best as long as we can get poultry litter on it. It really responds and does not lose productivity after land leveling. And really, the cost of land leveling, we want a high value crop out there like rice um, instead of soybeans and corn. So we had this field up top. Whoops, sorry about that. Let me go back one. I bumped. I still didn't go back. So anyway, we had this field up top. Then we had this field in the middle, and then the lower field. And so we had our sampling station we called Hague 3 up on the north field there, and you can see it would flow through a pipe. Now we use open channel pipe flow, which means that pipe is not completely filled with water. And open channel flow, then we can apply equations and we can estimate the runoff just like we would in a flume. But all that water flows into this field, and then we have this field, and then we grid sampled these fields, and this just is the grid layout. We did that every year for routine grid soil sampling and for some of our indicators for soil health. Again, we use the same type of equipment. We often use flumes, but in a lot of these rice fields, the farmer actually puts pipes in, and we just convert that. We use a area velocity meter rather than a pressure transducer. The area velocity meter is just a mini Doppler radar with a pressure transducer in it, but it allows us to calculate the velocity. We know the geometry based on the stage height in that pipe, and we can calculate then the flow. Now let's just go through some of these results. First of all, let's look at the precipitation by year. One thing that we get much more rainfall than y'all do. We get on an average about 52 inches of rainfall a year. And you can see in some of our months, we can get heavy rainfall in January through May. And that's one reason land leveling has become so popular is that those soils will sit there and be wet until we can get something actively growing and get our evaporative demand up. And you can see we can have some dry summer months, which means we have to have irrigation during those months. We can lose about a third of an inch of soil moisture through evapotranspiration during our growing months on our crops that we don't flood. But anyway, here is the rainfall. I want you to pay attention to this big rainfall events that we had in September of 2024 because it did affect some things. But again, most of our rainfall is not as clear as what y'all showed in up north, but we do have some seasonal patterns. Well, the first thing I wanted to do is kind of look at our data and the frequency distribution of runoff concentrations because you've heard the term median a lot today. I think in a lot of water quality parameters, we really have to focus on the median because we're not normally distributed. And this is what this data shows is that our frequency is dominated by concentrations in runoff that are very low, but much more frequent. But then we do have these outliers that account for some big loss events. There's just not many big outliers. So most of our runoff events have very low concentration, whether you're talking about nitrate or total nitrogen uh, or soluble reactive phosphorus and total phosphorus concentration. Now, one thing to remember when you don't have tile drainage, our mechanism for loss is strictly runoff. We just don't get enough vertical movement of water through our soils to utilize tile drainage because of that restricted flow layers up close to the surface. And so our runoff is going to be far greater in terms of inches a lot of times, and also percentage of the rainfall that we get, we lose to runoff. And I'll talk about that a little bit more in a minute. But if you want to look at the losses of pounds per acre through the years by each month, and look at it for the three different rates. Now, the gray is the highest rate. The middle is the area that we actually got runoff from the other field, and then the Hague 1 is the highest rate, but it's also the it was it was it was it wasn't flood irrigated; it was surface irrigated. But you can see in the early months, January, February, March, we don't see very high losses. We get into the growing season. This is probably around the time that we applied fertilizer and the first irrigation to the row rice. And you may have seen that this Hague 2 was actually receiving nitrogen before it was flooded. But then we get into the flood, you don't see much coming from. And nitrogen under flooded conditions, what we have found is once you apply your nitrogen fertilizer under flooded conditions, the rice crop will take that nitrogen that's in solution up very quickly, or we'll lose some to denitrification. We lose very little of it to runoff, and you see that. But look what we were seeing here, and I didn't show the nitrate data, but most of these losses during this time from Hagewood 3, we're not flood irrigating that. We're keeping irrigating about once a week through furrows, just keeping the soil, the moisture. But the runoff from that, we can lose more nitrate. Whereas in the flooded, we're either uptaking the nitrate or we're losing it to the air. And so on some of these things, it's kind of a trade-off. Do you want to lose your nitrogen to the water, or do you want to lose it to the air? And you can see that these total nitrogen losses were fairly significant for those three events during the June and July when the rice crop was actively growing. We're just, because of our irrigation methods of furrow irrigating, we're just flushing some of that nitrogen out. But you can see they're above 10 pounds per acre. And you saw what the average loss was from tile drainage. So we do have an issue with, if we're going to furrow irrigate, we're probably losing too much tailwater and losing more nitrate. Then we get out here after the rice crop is over, we probably had a little more excess nitrogen, and we lost it from the other two sites, the 2 and 3 ton sites. You can see, but we didn't lose it from the row rice. But part of this is responding to, at the time when we drain that rice field, we keep it flooded, but then we're going to drain it for harvest starting in September. And some of this was just getting into October, and it's probably reflective of just draining all that water through that, that pipe at the end of the growing season for rice. Phosphorus, notice we didn't have any big phosphorus losses during the growing season. It happened after that in that big cutting that floodwater loose and draining it off so that we could harvest. Now, in 2024, I mentioned that big rain that we got. We got it at the end of September, early October. Whoops. Let me go back. I'm having my technical difficulties today. I think it's age related. But you can see we did lose some bigger. Now we're only talking about 3 or 4 pounds per acre in these big events. But we did lose them when we had that big rainfall in the fall. We had some phosphorus sitting there ready to be moved, and we got the transportation. This one in October more than likely was due to flooding. I mean, pulling the flood. But these events here were probably due to that big rainfall total that we got in September and October. We didn't see it until early November. But again, these numbers are fairly small, except for these 2 or 3 big events that carried a lot of our nutrients off during those big events. One thing we also monitored was potassium. And if you look, and if you can remember those other graphs, we're losing potassium. We're losing it in January. We're losing it throughout the year, but we're really losing it in the fall. Potassium never gets incorporated into the plant structure. It stays soluble in the plant. So when we harvest and we leave rice stubble out there, you've got soluble potassium in that rice stubble. And if you get rainfall or runoff events, that potassium can leach out of that stubble. We like to keep the stubble to protect the soil, but we're also losing potassium. And we're losing an order of magnitude compared to the nitrogen and phosphorus. Now, potassium's not a water quality issue, but it is an economic issue. For our crops require a lot of potassium. And if we can figure out some way to keep that potassium in place, we could probably reduce our potassium fertilizer needs. Uh, and so, and I'm less sure about what happens with potassium added as manure as I compared to nitrogen and phosphorus. But we do know we do have soluble potassium in manure. It's not all, it's not like the organic forms of phosphorus and nitrogen in the manure that I know of. I've got to study up on that. But we are concerned about potassium losses. And one great thing about Discovery Farms, it's kind of old school science where you go out and you make observations and you collect data, not for the purposes necessarily of looking at objectives and writing a paper as an end product, but just simply trying to understand what's going on. And I think some of the speakers before me mentioned this. The value of this observational data is it helps us pinpoint where we need to learn more. So this observational data is a good precursor to more detailed and very concise research. It drives and kind of tells us where we need to be looking at some of these issues. And I think that's a real value of collecting this type of data. Now let's look at mean concentrations and see if they differed significantly. Now what we did is these are repeated measures. So we used repeated measures in our statistical model to look at this. But it's interesting because when you look at nitrate, you look at total nitrogen, even though we had 2, 3, and 4 tons of poultry litter, Hague 3 it was a little bit higher where we had in concentration. It was significantly higher there for nitrate, where we had the higher rate of poultry litter, but it wasn't for total nitrogen. It wasn't for soluble reactive phosphorus, total phosphorus. Uh, it was significant. The middle was significantly in the middle compared to the, and this one didn't really make sense to us but it could have been the difference in batch of poultry litter going on those farms. And if you do this by year, you don't see a lot of significant differences for any of these nutrients. We also looked at sulfate. You can see that these means were an order of magnitude higher than for potassium and sulfate as compared to total nitrogen and total phosphorus. But when you get down, you look at all the data, you can see some significant differences when you analyze it across all years, as if it was one continuous long data set. I do think what we may see is that year after year of application, we're going to see more separation in the concentrations as we build up some of these nutrients in the soil. But that's the other thing. Were we seeing change in the soil test information from these 3 to 4 years of applications, continuous applications? And we don't have that very, we're fairly new to having annual applications of poultry litter to our row crops. It's just been within the last decade. Before that, we used it for land leveling, and we used it when we had extremely high fertilizer prices, if we could find it. But I wanted to show this. One thing that happened is that poultry litter can have a liming effect, and you see that in all these fields. It starts to build up the pH, especially in this first field, where we had the 4 tons per litter. Here's the problem. Rice is very sensitive to soil pH. Anything above 6.5, it's going to create phosphorus and zinc deficiencies, and it's going to stunt growth. And so if we're going to use poultry litter in rice, there are some trade-offs. We've got to make sure we don't approach and get above that 6.5 pH. So we're going to have to soil test more regularly than every 3 years, possibly, that we've talked about, or that we recommend. Phosphorus, the nice thing is we increased it by 15 pounds in one field, 2 pounds in another field, and if I don't keep my finger off that mouse, and then just 4 pounds in the other field. This is much slower than what we saw in our pasture situation. And I think it's because so much more of the phosphorus goes to the grain in rice, and we remove that grain, whereas in a continuous grazed pasture, 70% of that phosphorus that's taken up by the crop is then eaten by the cattle, grazing cattle, and then 70% of that gets returned to the soil. And so I think in the row crop situation, our soil test phosphorus buildup is going to be a lot slower. Potassium, on the other hand, potassium really started building up. 89 parts per million, 75 and 68 in those three fields. The other thing that gave us indication that we are benefiting soil health is you look at our organic matter. We're low. 1.8% is where we started, but we got on average, we got about a 0.5% increase in soil organic matter over just these 3 years. And I'm telling you, we've had some long-term no-till plots where we didn't do any tillage for 20 years, and we've not seen any change in organic matter. I think for our soils, we have to have an organic source like poultry litter, maybe even cover crops being turned back under. We have to have that to build our soil organic matter up because we can burn through organic matter. We just have the right environmental conditions to burn through organic matter very quickly. And this I do more for our producers, but I do think, and this just comes right off Chat GPT, when you ask about what, I just asked the question, what does 0.5% soil organic matter increase achieve? Now, I'm not taking this as the absolute. I'm taking this as a direct, we're making improvements directionally. But it's estimated that that organic matter is about 10,000 pounds or 5 tons in the top 6 inches. It can retain 8 to 10,000 gallons of water. That's helpful in our crops that are not rice, because we're going to flood irrigate rice anyway. But we are in a water crisis, and so any little bit helps. And then carbon sequestration. We can sequester up to 2.5 to 5 tons of carbon, and we feel like we can do that better under flooded rice conditions because obviously in anaerobic conditions we're reducing the microbial activity. We don't see the aerobic activity. And you can see that we feel like through that organic matter, we can get 10 to 15, and that depends on your fertilizer prices. And I'm not sure what prices Chat GPT used to bring this up, but and really this is my only use of AI. Now let's look at kind of these changes in nutrients from a grid sampling or nutrient mapping standpoint. They put the poultry litter out in the fall to try to get it to where more of the nutrients are available by the time the plant needs it. We're going to have to look at the timing of that, but we soil sampled in the fall after litter applications. And this is what we started out with, on phosphorus. This is potassium. We were still calling for potassium fertilizer there, but we got it after 3 or 4 years. The field's much more uniform. If you look at that bottom right tile where I've got my mouse, and we're above the level of adding potassium fertilizer now, our soil test values are. We don't see that with commercial fertilizer, but we've seen it with the poultry litter being able to get it uniform and build it up like that to where it's not calling for fertilizers again the following year. Phosphorus, again, we were concerned about that. We have increased it some, but like I said, when you look at these 3 fields and you look at the average, very, very small averages, average change, I should say. But you see it is changed somewhat, and we didn't end up as uniform in phosphorus as we did in potassium. Organic matter, we did see that increase. We're seeing a higher percentage of the field being up above 2% than what we started out with. And we get about a 0.5% on average across the field. I did want to show you something though. Look at the organic matter here where we don't have flooded rice fields. We've got a change in soil test. This was at another site. This was soybeans, but they changed to Bermuda sodgrass and got away from that. And I thought it might do some things, but really, we're not seeing any change in organic matter, uh, or not much anyway, on those fields. Same thing for corn soybean situation. We're just not seeing the big changes in organic matter that we saw under the rice field. So it tells me we may have better opportunity to store carbon under rice fields than we do uh, in our corn soybean rotations. This was all no-till except for the change from soybeans to Bermuda grass. Obviously, they did some work there to get the. But let's talk about our key takeaways from this. One thing is our row crop farmers are not legally required in our state to utilize a nutrient management plan for applying poultry litter to crops. However, I would highly recommend that they do. Poultry litter samples obtained, you do all these fancy studies and use the fancy equipment. And one of the big things you find out is that we've got to test our litter before we apply it. So we know what kind of nutrients we're putting out. That's just common sense. But we had no idea. I had no idea of the nutrient variability we were going to see in the litter. In Western Arkansas, we don't see that type of variability in the litter from house to house. But in Eastern Arkansas, they buy that litter when they clean it out and they stack it outside in the fields. And they may sit out there different number of months. And I don't know if that or if it's the management or both in the house that's causing the wide swings. Uh, I even told poultry producers in that you really ought to be providing a litter test for the people that are buying your test. They said, we're not going to do that. It's just in such high demand. They don't care what's at the content. They just want litter. So I've told the row crop farmers it's going to be on you. You buy the litter. You need to litter test. But again, it's one of these things that was common sense. We probably could have figured this out from the first. We just didn't think about it being a big deal, but it is a big deal. And we're trying to get that message out. We do have a crop P index, but I think the way that we use the P index in Arkansas for nutrient management planning, our P index is just not fitting into a 5-year cycle. We don't just have a corn soybean rotation. We can have cotton, corn, soybeans, and rice all in the same field. Usually don't have cotton in there, but and then markets can dictate what crop we plant the next year. So we have no idea what, and that changes everything. And so to try to do a 5-year planning cycle, we just don't have a P index robust enough to do that. What we're saying is keep up with your yields. And Eric Simon has created a spreadsheet that we're going to get up online where you plug in your litter test, you plug in your crop yield, and you plug in your soil test. And we're going to do a nutrient balance approach. Just trying to keep up with possibly, and I think as we add more water quality data, one day we'll be able to say, and you need to subtract this because you lost it to there. The other thing I failed to mention is on this same farm, Chris Bry, one of my colleagues at Fayetteville, he's got several grad students monitoring greenhouse gases from these same type systems. And so we're hoping that we can better quantify carbon and nitrogen loss cycles. We know we get gaseous loss. We just don't know to what magnitude. But Chris's team is putting together some of that data. Along with the water quality data, we're starting to get more quantification of this cycling. Edge of field monitoring revealed that nutrient concentration in runoff water were most frequently low, with only a few but notable higher concentrations above the upper 95% confidence interval. So we really need to use the median here because the data is skewed, but we get a very, very low concentration when you look at our frequency diagrams. Most of our events have low concentration. The average mass load or the flow weighted concentration, um, if you look at all of our events, they average about 4 pounds per acre and 2 tons per acre. That gets to be pretty significant when you look at the number of events. We just haven't put together the cumulative data yet. We're in the process of doing that. Somebody said our studies always end with need for more research, but we do need more research on how to best utilize this on our row crops. I know you guys up north, you have a credit system for using manure that you can apply to any additional fertilizer you need. We have not done that. We probably are in the process of maybe looking at that. Some producers do it on their own, but we've got to come up with some type of credit system to account for that nitrogen and phosphorus that and potassium that was left over from the manure. Uh, the one thing that surprised me is although different litter application rates were applied, uh, we didn't see a whole lot of significant difference, and we certainly didn't see proportional losses, meaning that the higher the litter application rate, the higher the losses in runoff were. Now, Tim said something that over time you may start to see that, and I think that's true, and I think we will too, is if we kept up these rates. But really, a 4 ton per acre rate is not a attainable rate that we're ever going to use. We did that for the purposes of this study. But I do think as we do more and more applications, we're going to see a more separation between the rates. There was clear increases in nitrate loss from furrow irrigated rice as compared to the 2 flood irrigated rice. You're going to lose some nitrogen in these systems. It's just furrow irrigated, you're probably going to lose it more by water and runoff, and flood irrigated, you're going to lose it through denitrification. Although not of environmental concern, both potassium and sulfate concentrations were an order of magnitude larger than either nitrogen or phosphorus. And I keep hitting that mouse, and I apologize to you. We did see that repeated annual applications of poultry litter did increase NP and K levels, but from a water quality standpoint, the rate of increase of soil test phosphorus over the observation period was not alarming to us because we are removing the grain and some of the phosphorus stored in that grain. But we're going to recommend even harder to every 3 years or even more often to protect water quality, but also to keep this pH from building up to where it's a detriment to our rice crop. And so that's what I was saying. At a pH above 6.5, we have problems. We're going to have to really monitor that. Maybe not use poultry litter every single year. We may have to back off and let that soil acidify a little bit for our rice crops. Poultry litter did have a positive effect, 0.5% increase in organic matter. We also looked at active carbon. It did increase active carbon. And we did see wet aggregate stability increases. So after land leveling, we are seeing that we're building some soil structure back with the use of poultry litter and that sort of thing. We need much more research, educational, and technical assistance if we're going to make sure that, because we definitely want to use this resource on our fields. I think there is a soil health benefit, but we got to protect from a water quality standpoint. And with that, I'll answer any questions, but I really thank you for your time. And I really appreciate your patience in putting up with my technical difficulties. I couldn't keep my finger off that mouse.
Thank you so much, Mike. Amber is going to launch the CCA sheet and also the poll. So she asked me to facilitate questions for you. So we do have time for a couple questions. The first one is from Sally. And the question is there a fall cover crop that might be useful for potassium harvest and carry over to the next cropping season?
That's a great question. I'm in favor of using cover crops for some different reasons. I don't know. I think it could help with potassium as it absorbs that soluble potassium. We would have thought that potassium movement in water would not have been a big issue because of fixation, cation exchange, but everywhere we're monitoring potassium in row crops, we're finding order of magnitude losses. I do think cover crops could help, but you're going to have to manage those cover crops in such a way because once you terminate that cover crop, that potassium is still soluble in that plant residue. and it won't. And if we don't incorporate the cover crop, which we're not currently incorporating cover crops in Arkansas because we're primarily very low tillage, that you're going
Sure.
to leave a lot of potassium back up on the surface to move. So I think the jury's still out on whether cover crops are really going to help with that or not. I
Yep.
am a believer in cover crop, but I always, make sure people understand that the benefits from cover crops you don't always see right away. It may take 5 to 7 to even 10 years before you see it. And you cannot think of cover crops as a short-term investment. You've got to think of it as a way of farming to see those benefits, or at least that's what we're seeing in Arkansas.
Sure. Another question from Sally. Do you have estimates of soil loss in flooding agricultural systems?
We do. We don't see a lot of flooding during the growing season when the field's flooded, because if you think about the field being flooded, that flood is actually protecting from particle detachment from rainfall. That water's that those raindrops are just going to hit that water. And so we don't see a lot of sediment there. When we go to drain the fields, we can create situations that, yeah, you go to drain a rice field, even though it's a fairly low head, maybe 6 inches deep, the flood depth, but it can create quite a bit of suction that can pull and gouge that. But primarily where we get in trouble is oftentimes we drain that soil, it doesn't completely dry out, but the rice is ready to harvest, and we go into wet soils harvesting the rice, and then we've got to do some land planing and stuff, or land smoothing at some point without any cover out there. We've also struggled to establish um, cover crops after rice. The rice
Mm.
stubble is so thick, and finding a way, a lot of farmers burn it, but we're really telling them you're just losing nutrients. Plus, you're creating all kinds of other air issue problems. And there's some towns in northeast Arkansas that are saying, "Hey, you got to stop this burning." We're seeing a lot more cases of young children being affected by the smoke in the air and that sort of thing. So, uh, I just I don't know on you know we just got to figure some of those things out, Tim.
All right. Last question from Eric. Is there any potential to use urease inhibitors on the poultry manure to reduce the risk of loss?
That's a great question. We do use urea inhibitors with our urea fertilizer that we use for rice. As far as mixing it with I think here's one of the problems though. A lot of the nitrogen in that poultry litter is in the organic form, and almost as instantly as it gets mineralized, it can be we can have the right conditions for it to volatilize. And but I don't know. I don't. Nobody's looked at that I know of. Trying to use a urease inhibitor with poultry litter. That's a great idea. I know I
All
wasn't
right.
smart enough. I know I wasn't smart enough to think of that.
Sounds great. Thank you so much, Mike. Amber, do you want to wrap it up?
Yes. Yeah. Thanks, Mike. Thanks to all of our presenters today. I've already gotten some positive feedback about the interesting presentations, and it sure is interesting to see the differences among our different parts of the country here. So thanks for filling out that poll. And just so you know, we have recorded this webinar and it will be uploaded to the University of Wisconsin Extension YouTube site. We will send out an email to all of the registrants with the link to that once it's posted. So again, thanks to Mike, Tim, Alan, Heather, and Claire for presenting for us today. And take care. Have a good rest of your day.